So as I think you just heard, my name is Brendan. I work right now for Lightbend in professional services. So I do a lot of consulting and training. I've been doing consulting and training around Scala, Play, Akka, as well. We do Java side on both Akka and Play as well. I'm involved in Scala for about 7 years now, Akka as well. And I want to talk a little bit about something that I guess is a little bit of a shift. It's something that's starting to emerge, which is this idea almost of serverless programming. And Amazon, what I think last year, and it was initially just for Node, launched this framework called AWS Lambda. And I've started to play a little bit about it with Scala. And so I want to kind of introduce that, a little bit of the ideas behind Lambda, but also what I'm building and where I'm aiming, and trying to make it easy for these kinds of applications to just be simple. So of course I've gone way down the rabbit hole with macros. So we call the framework Quaich. If you're not familiar with it, a Quaich is sort of a traditional bowl that one serves whiskey in, and it's pronounced Quake like the earthquake or the game. And so Amazon had released a Lambda microframework for Python called Chalice. So of course when we kind of came up with the idea, we went back and forth as to what other drinking vessel to name. And ultimately, whiskey seemed like a good choice. So the idea here is, I was talking to Thomas Lockney, and he had pointed me at Chalice, and we sort of liked what we saw, and we liked the idea of a Scala version of this, and so we started going down that road and exploring it. As I said, we kind of went down, hey, what other drinking vessel can we name this after, since it was inspired? So of course the question now is, what does serverless mean? Because we all love buzzwords, which of course now need definition in order to nail down exactly what it is that we're talking about. So the idea is that Lambda is a serverless framework, as they put it, but it's fundamentally event-driven. It is, I almost think of it closer to the concept of a trigger, in the way that it works is it, certain events will trigger it, wake it up, and execute what you're looking to do. Right now it supports Node.js, Python, and JDK8. So obviously my first thought was, hey, if it's got a JDK, I can run Scala on it. And again, with the buzzwords, it's always sort of requires that definition. And what I guess distinguishes Lambda, or the idea of serverless, versus having to spin up my own virtual machine, running whatever I'm doing, having to pay the cost of having a machine running all the time, especially if I'm not doing that much. This is where it sort of runs it. We don't necessarily have the server instance now. And we just upload a jar. Amazon provisions it. There's a machine or whatever else behind it. But when there's idle periods, the event loop is essentially suspended. So you can see this with Lambda, where your first request after a new function or an update of a function will take a while, but after that it's pretty quick. But they're more or less suspending that event loop when you're not executing, so you're not being charged for running a server. So especially if you're doing something less frequently, it's a great model. And you can build pretty quick apps on top of it. So this is driven with events. You write and register a function which consumes JSON input. Now the JSON will differ based on the type of event, the source of the event. There's actually a ton of them which I haven't gone down the road yet. Mostly I'm doing the HTTP side right now. But they provide some pretty interesting stuff. You can do triggers from S3. So you can invoke a Lambda function if S3 has a change, or DynamoDB. HTTP calls through the API gateway is what I'm focused on mostly now. But there's also some other stuff, and one of the things I'm having fun playing with a little bit is, I think they just launched in the UK the Amazon Echo, which is sort of their voice-activated speaker. You can write Alexa skills for Lambda. So if you saw the long-running Pinky in the Brain joke, I'm working on an Alexa skill right now that you say, Alexa, are you pondering what I'm pondering? And it will come back with any of the possible responses from the many, many years of Pinky in the Brain. So that is sort of my exploration project for the Alexa side. But I am sort of trying to finish the HTTP, as well as the more challenging part that I'll talk about, which is actually trying to simplify the provisioning. Because like many AWS things, it's not necessarily the simplest thing to provision and set up, especially when you're tying together many systems. So we also can wire our own events. We could put whatever you want together, invoke the Lambda function from whatever code we want, but right now I'm sort of focused on those, hey, what are the pre-built events, the kind of stuff people could use, but a lot of what I'm building eventually could be abstracted. So the inspiration, as I said, was around this Python framework. I did a lot of Python over the years. I really like Microframework, stuff like Bottle and Flask, where it's very sort of decorator-driven if you've seen Python. So they released this in July. It was essentially a demo. They've updated a bunch lately, which I actually have to go back and see what other interesting things they've added. But the idea is it's what we really call a single-page app. It's one class that defines a bunch of routes. You don't have to write all of the registration of the JSON parsing. It takes care of it for you, and it just executes your app. So it's a really easy way to throw up a quick and dirty app. Now, keeping in mind as well that when we talk about the HTTP support in Lambda, it requires you to respond with JSON. So we're talking about something to build REST APIs and not to build a full UI-based system. But they used Python decorators. If you're not familiar with decorators, they look a lot like something like annotations. But what they actually are in Python is a higher order function. So your decorator wraps another method or function and allows you to add functionality or information. So you can define your HTTP routes pretty quickly and easily. So this is an example of one of their demos of a Chalice app, where they create their app with the name, but your routes. So if you request the route / you drop into index. If you request the route cities, with city being a substitutable argument, the open brace, closed brace is what's imposed by their HTTP gateway. But you now have access to the city, which it will automatically pass as an argument. And this is kind of the road that I wanted to go down. How do I do this with Scala? And I've spent a lot of painful moments playing with macros to get as close to what I want as possible. Looking a little further, you can also specify methods. So you get paste or put, go post or put. And I stayed pretty close to this initially, but I went down a road that I think is a little broader. I didn't like as much the idea of having one method handling multiple HTTP request types, and we've broken that down a little. But it's a good idea to start with. Now, it's not perfect. It uses the API gateway, which you have to configure by hand for the most part to route HTTP to your function. You have to configure the gateway, which is mostly driven right now by velocity templates. So let's go back to 12-year-old Java technology that I can't remember anyone actually using. The only place I think I've seen it is like IntelliJ's live templates. But they have added support recently for importing Swagger. So that's one of the things I'm looking at to simplify this. And the nice thing with Chalice is they've provided an app, a sort of plugin that can automatically deploy, set up your API gateway, and everything else. So there's a lot of interesting inspiration there for what to go with. And eventually we're going to have the same thing. I'm working on an SBT plugin, SBT being the build system that most of us use in the Scala world that will simplify this. So I will admit, to some degree, I have no plan. The nice thing about something like this is I can just keep playing with it until I'm happy with what it looks like. And anyone who knows me may not actually be surprised by this fact, that I'm just sort of winging it. So we have started hacking at it. I've proven a lot of what I want. I've refined it. I think I'm at the point where I like the way the API looks, and it's pretty close to how it's going to be. And now, of course, it's all the things behind the scenes. Right now it's a little bit of a Potemkin village. So Chalice only supports HTTP events, but eventually I want to support, have simple base traits that allow us to support lots of different concepts and ideas. But I am focused right now on getting something nailed down for the HTTP side. Because having a simple triggerable HTTP gateway is nice for something where I don't want it running all the time. And I'm looking in the next couple weeks to get a beta out that supports and demonstrates everything. And, this is more, I really should get that done and finish it. So this is a rough example of my equivalent of a demo app now, where it's actually mainly driven by an annotation. And in this case, in Scala, annotations, unlike Java, in the Java world, annotations are something that's a runtime code modification. In Scala, annotations can only be expanded through either a compiler plugin or a macro. So the idea here is I don't want to write all the event loop and all the custom handlers for parsing the request JSON, because Amazon gives you a request JSON structure, and then you've got to extract the actual body that was sent. So everything's taken care of, and that's part of the thing. Let's make this simple. So our routes are defined. Here I've got a get route that's taking a username and a bar argument. You can do a simple response with complete, and I'll talk about the pattern that was used here in order to handle that. And the same thing, we support all the major HTTP methods, simple response codes, and everything else. But this expands out in interesting ways. So this is a put handler that takes multiple path arguments, but the other thing is automatic case class deserialization. So the idea is you can define a case class that matches the spec of the JSON you expect, you pass it as your type argument, and you'll actually have request.body will contain that case class deserialized. Again, we take care of everything, we try to make it simple, and the path parameters come in a map. So right now, I kind of haven't gotten to the point of making types work the way I'd like to. I'm still playing with it. I've hit some odd corners of macros. But you also have access to query parameters and everything else. So you can define a pretty nice spec. And ultimately, HTTP Gateway allows you to define strict schemas. You could say, this is the strict JSON schema for request. This is the strict JSON schema for response. And a post handler looks more or less the same. The difference here is sort of showing as well two different types of response. That I can respond, for example, with a tuple containing both the response code and some content, or just a response code. And there's a bunch of other things using the magnet pattern here. But we still have that sort of nice deserialization of the case class N. And you'll note as well that I'm calling request, which is patched in through the macro. So the route methods, we support post, get, put, head options, and everything else. I think delete is not listed on there, but delete is there as well. And they're provided via macros. So I kind of went down that road as finding it was the best way to generate the code, minimize the boilerplate, and make things easy. So they'll generate a routing table entry. That's the other piece, of course, is all these macros patch in a map that's used to route a request to the right place. So when the request comes in, it parses the body, it passes it to the appropriate route. And eventually, the plan is to use those routes, to use those macros to kick out the metadata configuration so that the SBT plugin can just pick up, hey, here's the Swagger definition that defines what this looks like. If you want strict JSON schemas, it's all there and everything else. So sort of having that code gen gives that potential advantage. So the ideal environment, one of the problems that I definitely ran into was how do I respond effectively with multiple types of responses but still keeping things simple? And of course the eternal thing of, well, do I really want to lock people into saying you can only respond with case classes? And they may have some other complicated way of the way they want to do things. So the framework generally should take care of this serialization. It should make it easy for me. I should be able to do whatever I want within the guidelines of what I want. Otherwise, we're building Rails. There's one way to do it, and it's the wrong way generally. So I tried going down the route of type classes, but sort of the broad general use of type classes hits a lot of limitations. It's not quite the way we often think of type classes in Scala. It doesn't quite fit what we need. And what I ended up against is the magnet pattern, which Spray used. Now, the magnet pattern is not type classes, but it's a more refined use of type classes in order to handle this. And it fits really well. And there's a really good post by Matthias. If you search magnet pattern, it will, I believe, come up as the first search result. But the idea was to use this for response marshalling. In fact, the code for Quaich looks very similar to the code for Spray because it was done right, and I like the approach. The idea is to eliminate multiple response types. So Matthias talks about it in his post of you don't want to have complete as JSON or complete as case class or complete as foobar. It would be nice to just have a complete method and make this simple. However, the next step you go into, okay, let's use method overloading. Well, if you've worked with method overloading in Scala, especially if you worked in Scala prior to 2.8 when default methods were put in, overloading is painful. And the other problem is that when you get into things like type erasure, well, now it won't compile because the system sees clashes, because from the erasure standpoint, they're all the same method. Code duplication, as much as we all love cutting and pasting code and introducing bugs every time we update, you have limits on parameter defaults, you have limits on type inference, and a bunch of other things. So it's okay, I kept going back to this idea of type classes. And the idea with the magnet pattern is one method, one parameter. We have implicits and type classes to guide us through what we're doing. And it means I can provide a bunch of defaults, but you can very easily just implement that type class and go with what you need. So this is what it looks like now. That's the code for the complete. You pass a magnet, and it uses that to actually complete the request. So this entire method is defined once. The argument that it takes is the magnet. And instead of overloading, we use implicit conversions to what we call magnet types. And that's the part that you can plug in whatever you want. I want to return a case class. I want to return something else. Yeah. So there is a second layer of type class here that we use for the JSON marshalling. But this is where it looks. So the trait at the top is the template for the type class, for the response magnet. You can define your result, and there's an apply method that takes no arguments. And the actual arguments you provide is up to how you define your type class. So I have an implicit here that takes a status object. In this case, again, sort of taking the spray approach, what they call status object is a tuple of a response code and T, where T is any arbitrary type with a type class for a response marshaller. So absolutely anything that I want to use, great. I can plug that in. Ultimately, I don't have to lock you into using JSON for S here. That's something I'd like to in the long term. Right now, I'm using JSON for S, but I'd like people to pick what they want. There's 3,000 JSON libraries for Scala, and everyone seems to prefer a different one. And JSON for S is a good default, but I'd love to minimize the number of GitHub issues opened, asking me to add support for Cersei or John or anything else. Let's just nip that in the bud ahead of time. So the annotation is sort of what drives a lot of this, the way that we expand it, simplifying the code gen and everything else. It is macro-backed. It's a Scala annotation. But the idea is we generate the event loop handler. You don't have to deal with the interface that AWS imposes on you, which of course is Java-based, which means you get Java POJOs for things like the request body and the context and everything else. So I've got a case class wrapper that makes it a little more Scala-y. The default, deserialization of the JSON body and everything else. It will set up the routing table based upon your route request macros, and it will set up the request and context objects based on that incoming request. And it looks, if you look at the code gen for this, which we will in a minute, the idea, the thing I like about Chalice was its simplicity. Of course, Python being dynamic, they can get away with a lot of things that we can't necessarily in a compiled language, which is where sort of macros become the golden hammer, because when all you have is a hammer, everything looks a lot like a thumb. It's an important rule to remember. But you don't have to write all the hooks for event handling, certainly in Chalice, and that was the direction I was going in. There's no point in me writing this if you've got to write everything by hand. It's useless. So the parsing the request body, everything else, as I mentioned, every sort of type of Lambda or trigger that you use has a different JSON format. So right now we sort of handle the HTTP, but ultimately we can handle anything, Alexa or whatever else. So I took that extension to the macro annotation to generate our boilerplate. And if you've looked at macros before, I'm using quasi-quotes, which provide a lot more sanity. I don't have to write an AST by hand. As much as I've given macro talks before where I have 1,000-line code dumps of ASTs, which is the point at which people get up and walk out of the room. The point where I want to cry as it is. The idea, though, is I generate a companion object, and that's the part that Amazon calls. So the companion object implements their request handler trait and everything else, and that's the event loop handler. And then every request will create a new instance of your handler class, passing in the request, passing in the context, setting up the routes. And this is the quasi-quote template. So if you remember, I just had Lambda HTTP API, class demo HTTP server, and that was it. What we're doing is patching in constructor arguments for the HTTP request and the HTTP context, extending the HTTP handler trait, doing the 1,000 imports for JSON for S so we can actually use it, and just dropping in whatever body code you have. So we're really just adding everything so that your code compiles without having to do all the JSON for S imports, without having to extend the trait, without having to write the constructor, without having to generate the case, not the case object, the companion object. And from the companion object side, it's the same thing. This is implementing our HTTP app, which is just a wrapper to Amazon's base, passing in a new handler object. So that will accept the request from AWS and go and run. Which, I'm, of course, kind of patting myself on the back here. One other interesting thing that I discovered, the problem, of course, in Scala with working with macros is if you're in an IDE, all of those lovely red errors that tell you all your code is wrong. And I mean, that's fine for me. I know what the macros do. I know what they look like, but it's not terribly useful. So I'm working on a blog post for this for type level, but there turns out to be a somewhat undocumented API as part of the Scala plugin for IntelliJ that allows you to inject synthetic information. So you can write a handler that tells it when you come across this macro annotation, here is all the stuff that the macro annotation does to alter the decorated or annotated method or object or class. So I've actually written a plugin that's available for this that tells IntelliJ, well, we patch in this trait, we patch in these methods, we patch in these constructor arguments so these variables become available, which is nice because now I'm able to work on my demo stuff and everything else and not have the red errors, have the autocomplete, have IntelliJ actually able to tell me when I've coded the macros wrong, even though it doesn't know that, say, the get method exists. So it's a pretty interesting, I mean, it's not entirely undocumented, but there's only a few simple examples. And it turned out to be very easy to use. You're ultimately just returning a block of code where it's things like def foo equals triple question. It doesn't care what the body is, it just cares about the signature. The one problem that I've run into here, though, is really making the deploys sort of what I think of as stupid simple. How do I actually make deployment a sane thing? And the goal really is an SBT plugin here. But the idea so far, I'm leveraging a plugin that Gilt wrote. Unfortunately, all it really does is upload your Lambda jar into AWS in an S3 bucket, provision Lambda, but it doesn't do all the things for the HTTP gateway, the JSON provisioning, and everything else. And that's kind of what I'm dealing with extending at the moment. But doing the rest is very painful by hand. Every time I want to test, I find myself spending 15 minutes and wanting to cry and hide in the shower, hugging myself endlessly. And so that's something I want to automate. Because again, if it's painful for me, then there's no point in shipping this to other people. And this is an example of the coding process that I deal with when I'm working with Lambda. I go through a lot of keyboards. It's complicated, too, with the health insurance plans in the US. You know, the benefits of socialized medicine when you're that frustrated. So there is a roadmap. This is the place where a lot of my development is focused at the moment, is the SBT plugin. So I want to make this Excel, rapid development. You should just be able to do everything. It should pull the information, the metadata from your code as much as possible, some simple information configured in your SBT settings, and provision the gateway. Set up optionally. You know, maybe don't want it to be strict, but have the option of saying, hey, I know what the JSON that comes in as a request should be because I've said I want this case class. So there's no reason I can't define a JSON schema there and tell AWS, just reject it on your side if the schema doesn't match, so I don't have to deal with not being able to parse that JSON properly. In either patching in the velocity templates or the Swagger spec or whatever else that it takes to quickly provision that and have it be consistent. I mean, I don't want people to write that by hand because how do you make sure that matches up with the code that you've written? And most importantly, automating the development and release of your Lambda function. So the code lives under my GitHub. It's bw McAdams /Quaich. And there's a separate repo for the IntelliJ plugin and a separate repo for the SBT plugin. I think the SBT plugin is quarter cask right now. Again, you know, continuing with the whiskey reference. If you like Lefroy, that's the way to go. And no, I think I'm running a little ahead on time, unfortunately, so I have plenty of time for questions. Yes?
Just a quick query about the way you came up with the design for your DSL for the routing.
Mm-hmm.
Did you look at any other projects that do it? It was very similar to the FNAC for example. It has like case capacity.
Yes, so actually what I was most inspired, so the question, in case the camera didn't pick it up, was whether I looked for my routing DSL at examples of other things for the inspiration. And really the answer is yes. So I was at Netflix until the middle of last year, spent a year there, and we were working with Scalatra. And for me, I like Scalatra because I like the Python microframeworks, which look a lot like that. And that was sort of where I looked at. I like the simplicity. I think it worked better. Thomas argued with me about I initially did this with annotations, and I think it complicated things more than it should. And ultimately, that's the route we went down. And Scalatra was very much driven as the inspiration for that, to just make it simple. The one thing, and I'm still trying to fight with, is potentially injecting the path arguments as variables, and I can't seem to get Scala to accept the variables I've injected from the macro as something that compiles, unfortunately. So, other questions? Yes.
So it's interesting what you said about everyone wants to write their own JSON processing framework. I wonder if now starting to see the same thing with REST frameworks as well, because based off of Spray, after HTTP, of course, was the natural transition, and then HTTP REST and Finch, which was the great talk here last year about all taking that similar type class derived completion and path interpreting way of doing things. But what I was wondering was if you could just take an HTTP framework in Scala and then just ship it into Lambda, like if you could take an existing Play application, how much work would it be to write a wrapper that let you just put that into Lambda? What's the missing piece?
So the question then would be essentially all these other, I'm reinventing the wheel with them, complaining about everybody reinventing the wheel with JSON and then doing the same thing with HTTP framework. Could we patch something in? I think conceivably, yes. So Play would be interesting. I'm not sure where with the dependency injection and everything else. It would be an interesting question to explore. I think something like Scalatra or HTTP4S would be really easy to drop in there, because really you're just changing the event handler. Scalatra is capable of plugging into its own standalone server or plugging into Servlet, and there I think it would be easy to put a handler in. It probably could be doable with Play. It's something I'd have to look at. Because it's interesting. And the question I guess there is, certainly you're not going to be able to prevent views, so you'd still be building just a REST service. But for a lot of these, there's no reason not. It's a pretty basic API from Amazon. It says, implement this trait, have a method called new handler that gets a request object and a context object, and go. As long as you return JSON, you're okay. Yes?
Kind of response to that question, I think the use cases for Lambda and REST have something that handles hundreds and hundreds of queries and try and add similar services to handle those things. So where I won't be using Lambda a lot outside of HTTP, we use it a lot for handling those from S3, handling those from Kinesis, stuff like that. So that it feels to me that the size of them is the joy of it, right? You have a lot of small portable code that can execute. So you're not going to replace an entire Play application with a single Lambda code, but I don't know, to me that doesn't feel like the necessity of supporting that size of thing.
Yeah, the big applications don't necessarily make sense. It's almost nano framework. It's almost nano services. Very small execution method, and that's definitely something I'm really excited to explore too. Is all the things like Kinesis triggers, S3 triggers, Dynamo triggers, because that's the place where it's, hey, I just want to throw something up. I don't need to call this all the time. And those are, I'm kind of starting with HTTP. I don't know that HTTP is the thing that everyone's going to use, but it's that sort of gateway to all of these other things you can do. It's the proof of concept of, hey, we can make this work. We can make it easy for a Scala developer to just quickly put things up and prototype them, because running an AWS server is not necessarily an inexpensive thing, especially if it's not being called that frequently. Any other questions? All right, well, thank you everyone for your time. Apologize, I think I ran a little shorter than I intended to, but if you have other questions, feel free to let me know.